Hello guys, welcome to my channel, and today's topic is probability. Now probability is a topic that requires a basic knowledge of permutation and combination. If you know permutation and combination well, then probability is very easy for you. If you don't know them and you have doubts regarding permutation and combination, then probability is a bit harder for you. Here I have taken five questions from five different type of questions to show you that which type of question comes in joint entrance examination. So let's come to the first question. The first question is, an old man, while dialing a 10-digit number, after dialing 8-digit number, he suddenly forgot other 2 digits, but he remembers that those 2 digits are different. So he randomly dials 2 digits. Find out the probability that he dialed the correct number. Now, to solve this question, I assume that there are 10 numbers. Now the old man knows the first 8 digits, but he does not know the last 2 digits. So he does not know these 2 digits, and otherwise he knows these 8 digits. So now he remembers that these 2 digits are different. मतलब उनको पता है कि ये दोनों डिजिट अलग अलग है. तो if I assume now total number of tries that he can make to dial this number is 10 multiplied by 9, that is 90. As if I assume that he assume any of 1 to 10, so I can, as it is 10C1, and as 2 digits are different, so here is 9. He can select from 9 different digits, so here it is 9C1. So that is total number of probability, total number of chances is 90. Now as you all know that he is dialing a number, so the favorable condition is only 1. Favorable condition is 1, so the probability of the man that he dials the correct number is 1 divided by 90. So coming to the next question, P and Q are chosen randomly from 1 to 10 with replacement. Determine the probability of roots of the equation x square plus pq plus q equals to 0 are real. Sorry, it is px. So d here is p square minus 4q, and I have to find out that it is real. So d should be greater than or equals to 0, and that means p square greater than or equals to 4q. Now I have to take choices, that is when p equals to 1, p equals to 2, p equals to 3, p equals to 4, p equals to 5, p equals to 6, p equals to 7, p equals to 8, p equals to 9, and p equals to 10. So when p equals to 1, then 1 greater than or equals to 4q, so there is no q. When p greater than p equals to 2, that is 4 greater than or equals to 4q. Here q equals to 1. Here 9 greater than or equals to 12. So here, sorry, it is 4q. So here q equals to 1 and 2, and here it is 16 greater than or equals to 4q. Here q equals, here there are 4 q's, 1, 2, 3 and 4. Then here will be, when p equals to 5 it will be 6, and when p equals to 6 it will be 9. You can try yourself. And when p equals to 7 it will be 10, and further all there will be 10. So total number of p that we can get from here, total number of q that we can get from here is 1 plus 2 plus 4 plus 6 plus 9 plus 40. So it is 62. So the probability that here you can check that p and q are chosen randomly from 1 to 10. So the probability that the roots are real, that is probability of the event that the roots are real, is 62 divided by 100. as as we can choose randomly p and q from 1 to 10. So the total probability is, total number of choices is 10c1 for p and 10c1 for q, so that is 100. So that is the probability, and that's your answer. In this question, Vibgyor balls of 7 color. We have 7 color, different colors ball and 7 different colored box. So there are two questions. First one is find the probability that no ball goes to its own box, its own color box, and exactly 4 ball goes its own color box. So it's completely on dearrangement theorem, and it's very easy question. So there are 7 different colored balls and 7 different colored boxes. So first, for the first question, so we have to find the probability that no ball goes to its own color box. So we directly have to apply dearrangement theorem. So here total chances equals to factorial 7, that is 7 different color balls, and favorable condition is we have to apply directly dearrangement theorem, that no ball goes to its own colored box. So favorable condition is factorial 7. I am directly applying dearrangement theorem. You can check it. I assume that you know dearrangement. Minus 1 by factorial 3 plus 1 divided by factorial 4 minus 1 divided by factorial 5 plus 1 divided by factorial 6 minus 1 divided by factorial 7. So probability of this event equals to favorable upon total. You check it yourself, the answer. And for the second question, exactly 4 ball goes to its own color. Here also the total number of chances equals to factorial 7, and the favorable condition is also that 7 ball goes to its own color box. So it is 7c4, and the chances for this is 1, and rest of 3 you apply dearrangement for the rest of 3. So that is 7c4 multiplied by factorial 3 into 1 by factorial 2 minus 1 by factorial 3. So the probability of the event that exactly 4 ball goes to its own color box is 7c4 factorial 3 multiplied by 1 by factorial 2 minus 1 by factorial 3 divided by factorial 7. So answer, check it yourself. In this question, a pair of dice is rolled until a total of 5 or 7 is obtained. Find the probability that the total of 5 comes before a total of 7. So it is a question that is, you have to think harder. It's a very easy question if you think correctly. So to solve this question, now underline that the total of 5 comes before the total of 7. Now you have to remember that total of 5 will come before total of 7. So the solution will be, first I will assume that 5 comes. In the second try I will assume that 5 and 7 no one comes, that is 5 bar and 7 bar, and then 5 comes. In the third try I will assume that 5 नहीं आएगा, 7 भी नहीं आएगा, फिर से 5 नहीं आएगा, 7 नहीं आएगा, and then 5 आएगा, and this process will repeat continuously. So it is your probability, and the answer is probability of 5. Probability of 5, that probability that 5 comes is, that is 4 divided by 36 and प्लस प्रोबेबिलिटी दैट 5 एंड 7 दोनों ही ना आए, इसका प्रोबेबिलिटी है 26 अपॉन 36 मल्टीप्लाइड बाय 4 डिवाइडेड बाय 36 प्लस दिस इज 26 बाय 36 whole square multiplied by 4 by 36, and this process continues, and it is 4 by 36, you can take it common, and 1 plus 26 by 36 plus 26 by 36 whole square, and dot dot. You solve it yourself, the answer. And if you ask how it is 26 by 36, I will tell you that probability of A bar intersection B bar, it is 1 minus probability of A union B. So it is 1 minus probability that 5 and 7 both comes. So it is 1 minus probability of 5, that is 4 by 36, and probability of 7, that is 6 by 36, and it is 0. So it is 26 divided by 36. You check it yourself. The last question, and it is a geometrical problem, and it is very easy. मतलब बहुत ही आसान है. So this question is, a point is selected randomly from an equilateral triangle of side A, side length A, and what is the probability that its distance from vertex greater than A by 3? So I am drawing a triangle, sorry, that is equilateral triangle, its side length is A. That is A by 3, I assume. So what is the they are asking that find the probability that its distance from vertex, these three are vertex, is greater than A by 3. So it would be an arc, it would be an arc of radius A by 3, that is A by 3. Here also it will be an arc, and here also it will be an arc of radius A by 3. So what they want is the probability that the distance from vertex should be greater than 1 by 3. So the point should not be at this position, the point should be here, that is 1 by 3 distance greater from vertex. So this is a geometrical problem, and its solution is, so favorable condition is the area of this position, that is total area minus this 3 area. The total area is root 3 divided by 4 and A square minus 3 times this area. This area is half pi by 3 and A square, that is A square by 9, and the total area is root 3 by 4 and A square. So the probability of the required question, the probability is favorable by total, that is root 3 by 4 A square minus 3 pi A square by 239 divided by root 3 by 4 A square, and that is your answer.